Hello everyone, welcome to the next lecture. In this lecture we shall see problems related to triangle. We shall quickly see the concepts. A triangle is a three-sided closed plane figure which is formed by joining three non-collinear points. That is, the points will not lie on a straight line. We can categorize the triangles based on sides or based on the angles. Based on sides, if all the three sides are equal, we know it is equilateral triangle. If two sides are equal, we have got isosceles triangle. Or if all sides are having different length, we have scalene triangle. And based on the angles, if one angle is 90 degree, we got right angle triangle. If all the angles are less than 90 degree, it is an acute triangle. And if one angle is greater than 90 degree, it is obtuse triangle. We shall see the other concepts. For a triangle, the sum of two sides is always more than the third side. And the sum of three internal angles is 180 degree. You can see the angles ABC will sum up to 180 degrees. In right angle triangles, the square of hypotenuse is equal to the square of base plus square of the height. That is, a square plus b square is equal to c square in this right angle triangle. And next is similarity of triangles. Two triangles are said to be similar when the shape is same. Even though the size is different, the shape is same, then it is called as similar triangles. Here we can say one triangle is scaled up or scaled down of the other triangle. In this example, we can see the two triangles are similar in shape. The ratios of the sides, corresponding sides will be constant. That is, AB by DE is equal to AC by DF, which is equal to BC by EF. So the ratios will be same. So this is the fundamentals of similarity of triangles. Next we shall see orthocenter. Orthocenter is the point where three altitudes of the triangle meet. That is, here an altitude is a line that passes through the vertex and is perpendicular to the opposite side. Here we can see the line AD passes from the vertex A and it is perpendicular to the opposite side BC. Similarly, the other two altitudes CF and then BE. Here the common point of all three altitudes is called the orthocenter. Next is the incenter. The incenter of a triangle is the intersection point of all the three interior angle bisectors of the triangle. It is also the center of the inscribed circle. That is, if you draw a circle inside the triangle which is tangent to all three sides, then the center is called the incenter. It is also the common point of all the three angle bisectors, that is CP, BM and AN. These are the angle bisectors and that lies at a common point called the incenter. So both the circle center and this angle bisector common points is called incenter. Next is circumcenter. Here it is the point where the three perpendicular bisectors of a triangle's sides meet. It is the circumscribed circle's center. So if you draw a circle outside the triangle connecting all the three vertex points, then that center is called the circumcenter. It is also the common point of all the three perpendicular bisectors of the triangle's sides. That is, here it is not touching the vertex, but the bisectors are perpendicular to the sides and also it is bisecting the sides. So all the three bisectors will have a common point, that is the circumcenter. So we can see the difference between orthocenter, incenter and circumcenter. Next is median. It is a line segment that connects a vertex to the midpoint of the opposite side, dividing that side into half. Here we can see the line AD splits the side BC into BD and DC at equal distances. Similarly, the other lines also. And the common point is called the centroid of the triangle. And these lines are called medians. The centroid is the point where all three medians of a triangle meet. The centroid divides each median into two segments in the ratio 2:1. That is, the length AG and GD are split in the ratio of 2:1. And the centroid formula is given here. It is the average of all the x vertices, average of all the y vertices. We shall quickly see the formula. The area of a triangle is given by half into base into height. This is well-known formula. Next is the area of a triangle where the three sides are given. That is side A, B, C. We can formulate the area as A is equal to square root of S into S minus A into S minus B into S minus C, where S is the semi-parameter. That is half of sum of all three sides A, B, C. And another formula is A is equal to half of AB into sin theta. That is half of the product of the sides and the sine of the angle containing these two sides. where AB are the lengths of any two sides of the triangle and theta is the angle between them. This is another formula. So you need to remember all these three formula mainly. And next is the equilateral triangle. Area of an equilateral triangle is equal to square root of 3 by 4 a square. You can also derive this formula from area is equal to half into base into height. This height will be equal to square root of this hypotenuse square minus half of this other side square. So you can calculate this. And the altitude of the equilateral triangle is square root of 3 by 2a. And the perimeter is 3a, which you know easily. Next is radius of incircle and circumcircle for equilateral triangles. So we can see here the incircle is present inside this triangle and the radius r is given as a by root 3. And the radius of circumcircle of an equilateral triangle is r is equal to a by 3. We can see here the ratio is divided into 2:1. That is r will be 2x and then smaller will be 1x. So if you know the radius of incircle, we can easily calculate the radius of circumcircle. And the last one, the radius of incircle of a triangle of area A and semi-perimeter S is equal to a by S. This is for an equilateral triangle. Okay, we shall solve few problems in the next lecture. Thanks for watching. I will see you in the next video.